All right. Work on embedded projects for Asurion. There's no real reason to hide it anymore. Yeah, beep. On embedded IoT projects that we're doing ground up design. There was a cool meme there, if you can guess what happened to it. That way. All right, so I started working off operating systems for Android, AOKP, AOSP, and CyanogenMod, and those sort of things. I started doing it, that's how I learned. I wrote a tool to interact with a Garrett review system, which is Google's code review system. That app got pretty popular. Then I went to work on servers, started playing with security, learned Python, and then started moving into some other stuff that was fun, and yeah. So what are we here to discuss? Not me. Right? So what can we do when we run into a box? Let's say we pop a box that is a very, very simple box. If you pop my IoT box, it's not going to have Netcat on it. It's not even probably going to have Busybox on it. Now, why does that matter? So we can get a lot of things off the box through just the kernel. We can get a lot of information from the box without launching external processes and launching processes that are AVs and things like that can pick up on, right? So we were talking earlier, no one cats Etsy password, right? What if I don't use cat? What if you're looking for cat and I never use cat? Great. So that was a lot. What the world? All right. So if you do ever get on a box and you find something called Busybox on it, you have the world. Busybox contains everything, or at least a version of about every Linux tool you've ever thought of. And in fact, most of these tools you probably assumed would come from a default Linux installation. They don't. These are external tools. So this is not part of Bash. Busybox actually it's a multi-call binary. So a lot of these tools are actually symlinked into Busybox. So when you call things like chomod, it's actually forwarding off to Busybox space chomod. And then you're executing this command. Now, some distributions will actually write their own binaries, and they have their own versions of true and false, because why wouldn't you write your own version of true and false, right? And that's not there, right? So we don't have most of the tools that we typically have. So what do we have available? Well, it turns out the default bash shell will actually tell you what you can do. Now, you probably don't actually use most of these commands. You probably know echo, you probably know cd, and exit, a few of those. But what can we really do with these things, and how can we utilize them to mimic some of the functionality that are more advanced tools? Advanced, Busybox, again, these are advanced compared to what we're using right here. So how can we get through? So these are our bash internals. These are the required to be bash things that we can use. So now, once we know where our functions are, where can we start getting information? Where can we start getting where can we start looking, right? So the first thing we're going to do is look for any functions declared within the shell. A lot of times, they will have a lot of these functions that replace the common tools. They'll have a developer who needed a timeout. So they wrote a snooze function. And they'll load these into the shell, but they won't be binaries, because binary searches will show that. Declared FF will show all custom functions loaded through the environment. This is a great, great way to research things, because a lot of people put a lot of things in the environment, assuming no one can ever get to it. So if I can't get there, where can I go? I can go to imtab and find mounts. The temp file system contains memory that was supposed to be paged out in different ways. Not quite paged, because that goes to the swap, but there's memory there you can pick up from. All right, so from process, what can we get from there? We can get the command line that you use to launch. We can get the current memory, the current PID. We can get all sorts of information. From the sys, we can actually talk directly to the kernel. Now, this doesn't sound like a big deal, but what if I what if I popped an industrial control system, right? Those little GPIOs, they blink lights. Those lights probably mean something, right? Maybe important. I keep forgetting I can't point it at the. All right, so. A lot of this is going to be review if you've ever been working on a low-level system that doesn't have these tools, because you tend to improvise and you're going to need to do these things. So I just wanted to throw up a couple of different things you can do with printf. Printf turns out to be about the most useful thing on a computer. It will do almost anything echo will. It'll do almost anything cat will. It's an amazing tool. You can use it to print 1 line, 10 lines. You can use it to replace hex with ASCII. You can use it for all sorts of things. It's amazing. You should really spend more time looking at printf. All right, so now sysfs is really, really interesting. It classifies the kernel into classes. So it takes the kernel and breaks it down by functionality and then organizes it by classes. You'll find really interesting things like I don't know if you probably didn't notice, but on the first slide, there is no built-in date. There's no date time built in. So you might find a reason where you want to look at the time since approach if you needed a timestamp, right? If you need a date time, those are kept by the clock, but you need to know where to look. It's in the sys class real-time clock, right? And you may find multiple real-time clocks on a system for various different reasons and different control systems and things like that. Why would you want to know someone's MAC address? If you were trying to find them on a network, right? And you were trying to find yourself on a network, would that be interesting? Maybe. Okay, so this one right here, this doesn't seem like a big deal, but really what you're asking the kernel is tell me everything you know about. And this is important because you can look and see ahead of time whether or not the kernel has firewalls loaded into it. So maybe you don't want to trip a firewall, right? But you still want to make an external call. Probably not a good box to do it from, but it's good to know that ahead of time, right? Stupid. All right, so Proc NFS. Proc NFS is a really, really fun file system. So this is one of those invented here Linux things, right? So Proc NFS, you can actually, this first line here, you can pretty much mimic PS in its entirety. You can really get a little more scripting in it and include all the extra stuff that PS util will actually print out. But if you just want the basic procs of what's running and what commands were used to launch it, that'll do it. You might use to pipe it through more so you get some of the output, but that'll do it. And then if you need to know your current PID and GUID, do you know launching ID, the command itself, is an external process that can be picked up? This isn't. Printf through proc self status is not a call through a file system. It's a virtual call through the kernel. So unless they have a kernel module in there looking for people asking about themselves, how are they going to know? And some really fun other information you probably, if you were reconning a box, would be interested in, right? Some network information that you've got. Also, that really fun one on the bottom, that ARP. So a lot of times, these boxes are just sitting there listening on the network, right? Whether or not they're actually talking to everything else on the network, a lot of them are still hearing the ARPs. Do you know what the kernel does with that? It just sticks it in a little cache. It's like, I'll hang on to that. Just hang on to it. So you start looking in that file, and all of a sudden, you may find other things that have just been talking on the network and happen to have heard. So it's a good thing to look around in these classes. I am probably the only one, because you guys are all way smarter than me, that thought this is where the developers put their code, right? It's definitely not a device node. So this is the device. And while it's not quite as fun, the snooze command, again, I said it earlier, there's no timeout in the default shell. I'll define that function in the last slide I'll show you, but just assume it's a timeout-esque function. So what if we didn't have something like wget and curl? Wget comes from Busybox. So we don't have any network utility, no network stack utility to deal with, do we? Well, we have the kernel's network stack. Why don't we just send it to the kernel? So if we start sending virtual pipes into TCP/address or URL/port, the kernel's IP, the kernel's network stack will translate all that, send it off. Now we have to also read from it. We have to write from it and read from it, and it gets a little complicated. And how you do that, as you notice from the next one, we try to download a file. And what we end up doing here is setting the internal field separator to various things in order to get the file. We can get into that. But there's some really powerful stuff here, because a lot of people, if you tell them they're on a command line and they can't get to wget or curl, they're stuck. Or ncat, something like that, right? They're stuck. But that's not a reason to stop. That's a reason to think differently. All right, do that really fast. These are some of the fun functions I came up with while I was researching all this. So there were a lot of really things you need to do, like if you're trying to push something into memory or trying to stack overflow, buffer overflow something, and you need to know memory access, or you need to add hex or things like that. Sometimes you need to convert things to hex, to hexadecimal, to back forth. A snooze function, you can actually execute things over and over through a pipe, and it'll cause a snooze if you do it just right. And there's some really, really cool stuff. So this one right here, whoops, probably shouldn't do that hard. It's going to go through and ARP the entire network. and try to find all the IP addresses on the network. So there's a lot of things we can do without actually involving any external commands. And any external process we launch can be monitored. So if we can stay within the same process we're in, then we avoid detection. Well, we avoid a layer of detection, right? There can always be things outside of that we can control. And I think that's it. Yeah, last slide was a questions meme that they may remove, because why not? I should note, though, if you were to attack a Windows box, the exact same concept would apply. Using the Windows API through the shell that you're in and that you popped originally is going to be a much more solid approach to living off the land. You're going to be able to move faster with less detection footprint than you would be able to. As soon as you start launching external processes, all sorts of fun next-gen software comes online and goes, wait a minute. So keeping things within your own process is going to really benefit you. Anyone have any questions? I kind of ran through that really fast. All right, thank you very much. My Jaybird Vegas, Jaybird_Vegas, I'll put the slides on